The topic is balancing chemical equation. Remember, on page 18 of 20. I hope you're on page 18 of 20.
Yes.
Balancing chemical equation. Chemical equations. All right. Now, for each side of the equation, what I mean by each side of the equation is the equation is divided into two sides, separated by this arrow. This one on the left-hand side is called reactant. Called what?
Reactant.
So the reactants are HCl and NaOH. HCl stands for hydrochloric acid. NaOH stands for sodium hydroxide. Those are the reactants, the ones on the left-hand side. Then the ones on the right-hand side, that's the right-hand side of the arrow, are called products. Are called what?
Product.
Remember, they are separated by the arrow. The arrow is like a bridge. The ones on the left-hand side of the bridge or the arrow are called reactants, while the ones on the right-hand side are called products. So give me the compounds in the reactant side. You can mention their name or just use letters to mention their names.
Hydrochloric acid
Good.
plus whatever.
Sodium hydroxide. NaOH, which is sodium hydroxide. Okay, give me the compounds that are on the product side.
Sodium chloride plus H2O.
Sodium chloride plus H2O. H2O stands for water. Sodium chloride is what we call common salt. Alright, so what we do is, on the reactant side, we will count the number of hydrogen atoms. Hydrogen atoms. But first of all, you need to understand what I mean by the number of hydrogen atoms in each case. So I will use this to illustrate. Look at this. If I have CaCO3, how many oxygen atoms do you have here?
You have
3 oxygen atoms. How many carbon atoms do you have? If you have an element without any number as a subscript, it means the number is 1. It means the number is what?
1.
So we have 1 carbon atom. How many calcium atoms?
A.
No, Ca is they are together, Ca. That's a symbol of calcium.
1.
So calcium atom is 1. Carbon atom is also 1. Oxygen is 3. So altogether, how many atoms do we have in this compound called calcium carbonate? How many atoms?
5.
5. 1 calcium, 1 carbon, and 3 oxygen. Okay, let me tell you something. By the way, let me write the things down that you said. Calcium is 1 atom. Carbon is 1 atom. While oxygen is 3 atoms. Sometimes you may be asked, how many atoms are altogether in this? 5 atoms altogether, isn't it?
Yes.
Now, if I write this, if I write 2, then the same thing, CaCO3. How many atoms altogether do you have?
5.
Well, it was 5 when nothing was written on this side. You know, on this side is what tells you the number of moles. This one is just 1 mole. Remember, let me even indicate that you have 5 atoms altogether. But now you have 2 of it. If 1 is 5 atoms, so 2 of it will be how many atoms?
10 atoms.
10 atoms. Now let's write the number of atoms in each case. How many atoms do you have in oxygen?
3.
Remember, you already have 3. So each number will multiply this yellow number outside. So altogether, how many atoms of oxygen do you have? I said what it had originally. We multiply this number written in yellow. So, are you still listening to me? Okay, so that means for oxygen we have 6 atoms, because you are going to have 3 times 2. All right, that's for oxygen, 6 atoms. For carbon, we have, it was originally 1 atom, so it will be 1 times 2, which is now 2 atoms. And for calcium, it was originally 1, so altogether now it will now be also 2 atoms. That's why when you add up everything, you have 2 plus 2 plus 6. That gives us 10. 10 atoms altogether. Okay, so you need to take note of all this. So I was trying to tell you something about number 3. For number 3, what we do is we check each element on the reactant side and we compare it with the element, we compare it with the same element on the product side. Starting with hydrogen. How many atoms of hydrogen do we have on the reactant side? We have 1 here for hydrogen and another 1 here. Altogether 2, that is 1 and 1, 2. So on the reactant side, we have 2 atoms of hydrogen. We come to the product side. This is the product side. How many atoms of hydrogen? We also have 2. So hydrogen is balanced. Once you have the same number for both reactant and product, is balanced. So we can mark hydrogen balanced. Hydrogen is balanced. We check another one, chlorine. How many atoms do we have in the reactant side? 1 for reactant side. Let's check the product side. How many atoms do you have for chlorine in the product side? 1. So chlorine is also balanced. We mark chlorine. I will mark chlorine with a blue marker. Chlorine is balanced. Finally, no, we have sodium. We come to sodium. How many atoms do we have for sodium on the reactant side? 1. Only 1. We go to product side. How many atoms? Also 1. So sodium is also balanced. I can mark sodium with a green marker. Finally, oxygen. How many atoms do we have for oxygen on the products on the reactant side? 1. How many atoms do we have for oxygen on the product side? Also 1. So oxygen is also balanced. I can mark oxygen. Let me mark oxygen with red. So oxygen is balanced. Oxygen is balanced. So it looks like everything is balanced. We have everything balanced. Since everything is balanced, we don't need to write any number there. If you want to write any number there, you can just write 1, 1, 1, 1. But there's no need, because 1 doesn't need to be written if it is 1. So let's look at another example. Let me look at example number 9. I will start from the ones that you can easily understand. Let's see example number 9. Okay. Similarly, we check the reactant side and we check the product side. Reactant side. Then after the arrow, you check the product side. For the reactant side, we have how many atoms of sodium? Let's start with sodium. Sodium is 1 here. For the reactant side, you have 1 here. But for the product side, you actually have 2. So sodium is not balanced. Since sodium is not balanced, there are 2 atoms of sodium on the product side, whereas it's only 1 on the reactant side. So it's not balanced. What we can do is, we try and put a number here. You can use a pencil for this, because if you write and then you discover that it shouldn't be, you can erase it and change it to something. So I start with 2. So with 2 now, sodium, we have 2 atoms of sodium now on the reactant side. Let's check the product side. We also have 2 atoms of sodium. Let's check oxygen now. Here there are 2, because 1 times 2 gives you 2. So altogether we have 2 atoms of oxygen in sodium hydroxide with 2 molecules. Sodium hydroxide 2, because we have 1 times 2. Remember what I told you here? Anytime you have a number here, you have to multiply that number with the number of molecules to get the total number of atoms. So, for instance, 3 times 2 gives you 6 atoms of oxygen. 1 times 2 gives you 2 atoms of carbon. Also, 1 times 2 gives you 2 atoms of calcium. So that's what you should take note of. So in this case, is 1 sodium times 2. That gives you 2 atoms of sodium. Let's check here. For sodium, is balanced. Let's check if it's balanced. 2 atoms of sodium. By the time we add the 2 now, that's these 2 here. We have 2 atoms of sodium in the reactant side. Let's come to the product side. We also have 2 atoms. So sodium is balanced. But let's check. I will mark it temporarily. Let's check for oxygen. For oxygen, we have, continue to pay attention. We come to this sodium this number 9. Look at this number 9. I'm on number 9 now. Look at sodium. You know, I told you, when you look at the reactant side, you compare with the product side. Pick any element, pick one element, and check how many atoms of it you have in the reactant side. Now, also check how many atoms of it you have in the product side. If they are equal, then it is balanced for that element. Let's look at sodium. How many atoms of sodium do we have for question number 9 here? 1. How many atoms of sodium do we have here on the reactants, on the product side? 2. So sodium is not balanced. That means we need to add a number here. You can use you can always use a pencil in case you will need to change it. It's better to use something you can erase later, because sometimes you will discover that you need a different number. So if we have 2 here, altogether how many atoms of sodium do we now have?
No, not.
On the reactant side, how many atoms of sodium do we now have?
3. Sorry, yeah, 2.
2. How many atoms of oxygen in this sodium hydroxide? How many atoms of oxygen?
Oxygen 1.
Remember, you need to say 1 times 2.
Yes.
Don't forget what I explained to you here. This CaCO3 we call calcium carbonate. For oxygen, it had 3 atoms. But then you need to multiply it by the 2 outside to make it altogether how many atoms?
12.
I said for oxygen. For oxygen. Make sure you are paying attention.
3 times 6.
Make sure you are paying attention. So 3 times 2
Exactly 6.
gives 6. For carbon, how many atoms did he have initially? 1. You multiply by 2, so altogether 2 atoms, and so on. That's also for calcium. 1. Whatever, if there's no number here, it means it is 1. Then you multiply by number here. That's 2 atoms. Okay. Let's apply it here. How many atoms of oxygen do you have here in this sodium hydroxide here in this question number 9? 2. You have to add up all the oxygen in the entire reactant side before you get to the arrow. How many atoms of oxygen do you have here? How many atoms of oxygen do you have here in this H2CO3?
5.
So 2, do you mean 3 plus 2 to give 5? Is that what you mean? For H2CO3, we have 3 atoms of oxygen, because it's only 3 that is written for the oxygen. This 2 is for hydrogen. So we have 3 here, together with these 2 we found here for sodium hydroxide. That's 5. So oxygen is 5. Maybe I can even write it down for you to see. Sodium. Okay, the best way to do it is to use a table. That's for number 9. I'm answering number 9. I can draw a table like this. A table, the one for sodium, the one for oxygen, the one for, okay, how many elements? Okay, I have sodium, oxygen, then the one for hydrogen, and then finally carbon. Sodium, oxygen, hydrogen, and carbon. I write the same thing on the reactant side, on the product side. Sodium, oxygen, hydrogen, and carbon. We found out that after adding 2 here, altogether we now have 5 sodium on the reactant side. Oh, I said 5. It's actually 2. 2 sodium on the reactant side, because there are 2. And then for the product side, we also have 2. So we also have 2. So we can say sodium is balanced. Now we come to oxygen. This is, with these 2 outside here, it means oxygen is now 2 here. Together with these 3 atoms of oxygen we have here, that makes oxygen to be altogether 5. So oxygen is 5 in the reactant side. When we get to the product side, we have oxygen 3 here, and only 1 here. 3 and 1 gives us 4, so it's not balanced. If I written the 4, you can see that oxygen is not balanced, whereas it is 5 in the reactant side, it is 4 in the product side. So what number can we add here? It's only here that we add numbers. It's only here. You don't add numbers down. We don't add numbers as subscript. We cannot add numbers as subscript. Otherwise, it will become a different compound. We only add numbers before it, which gives us the number of moles. So what number can we add here? So that oxygen, that is 5 in the reactant side, will also be 5 in the product side. Already it's 3 here. We need it to be 2 here. So that 3 plus 2 will give us 5. And we can't write the 2 here as a subscript. So we should actually write the 2 here. So that now oxygen will be, let's count. In here it is 3 plus here 2. You know it's 2 because this is 1 times 2, 2. So 3 plus 2 gives us 5. So oxygen is also balanced. So we change this thing and make it 5. We go to hydrogen. Hydrogen, how many are there? We have 1 here times 2, which is 2. And then 2 here. So 2 plus the 2 in sodium hydroxide, 2 in hydrogen carbonate, plus the 2 in sodium hydroxide gives us 4. So in the reactant side we have 4 hydrogen. Let's check the product side. Product side is altogether 4 because 2 times 2 will give us 4. So product side is 4. We have 4. It looks like hydrogen is also balanced. The final work we have is carbon. Let's see how many carbons we have here. Carbon is 1 here, only 1 atom. And then that's on the reactant side is only 1. So we write 1. On the product side, we also have only 1 carbon. So we also write 1. And then we check. 2 for sodium in the reactant side, 2 for sodium in the product side. 5 for oxygen in the reactant side, 5 for oxygen in the product side. Same for, that's the way it is for hydrogen, 4 here in the reactant side, 4 here in the product side. And then also carbon, 1 in the reactant side, 1 in the product side, so it is balanced. And if it is balanced, we've done achieved our aim. And that means this one we have 2, this one we have 2, and that will make it balanced. Every other thing will just be 1, 1. If you like, you can write the 1, or you can just leave it. In real examples, you leave it, but I just wanted to show the 1 here, to show that there's nothing you need to multiply to it. Which other example can I use? Let's see. Example number, let's try 10. 10. So this is number 9. So let's do for 10. I'll rule a black line here so that we use that and do for 10. This is for 10 now. For number 10, which is this, we have potassium. So I will list all the elements. For the reactant side, I will use yellow. So potassium, then oxygen, then hydrogen, then bromine, and then rule a line. For the product side, the same thing. Potassium, for the product side we have potassium, For the product side, for potassium, we also have potassium and all that. Potassium, oxygen, hydrogen, and bromine. All right, so we check. How many atoms of potassium do we have in the whole of the reactant side? Only one. There's no potassium here, so only one atom. So we have one here. We check the product side. How many atoms of, remember the product side is after the arrow. The reactant side is before the arrow. Before the arrow you have the reactant side. Then after the arrow you have the product side. So for the product side, how many atoms of potassium? We also have one. So potassium is balanced. We come to oxygen. How many atoms of oxygen? We have one. So oxygen is one. We check the product side. How many atoms of oxygen? There's only one here. So it's also one. Then we come to hydrogen. How many atoms of hydrogen? For the reactant side, we have one here plus another one here, altogether two. So that gives us two. Then we come to the product side. How many atoms of hydrogen? Here we have two. We check again. Finally, bromine. How many atoms of bromine? On the reactant side, we have one. We have one. How many atoms of hydrogen do we have on the product side? Here, we also have one. So it means bromine is also balanced. Potassium is balanced with both reactant and product. Oxygen is balanced, both reactant and product. Hydrogen is balanced, both reactant and product. Bromine is balanced, both reactant and product. So it is balanced. We don't need to add any number here. It could just be 1, 1, 1, 1, if you like. That's the same thing we do for the rest. You can try any other one among here. The same method. I just use this to illustrate. Finally, I can do one more. Okay, let's see this number 4. Number 4. Or let's look at number 5. Number 5. I want us to put numbers here that will make them balanced. Let's check. First of all, carbon. How many carbons do you have here? 1. On the reactant side, altogether 1. Let's go to the product side. How many carbons?
1.
So carbon is balanced. It's 1. But all other ones must also be balanced. Otherwise, we have to write some numbers here. Okay, let's check for sulfur. How many do you have on the reactant side?
On the reactant side, 8.
We have 8 on the reactant side. How many do we have on the product side? 2. You can see that is sulfur balanced?
Sulfur, no.
So So what number do you think we can write here so that sulfur will be balanced? What number can we write on the product side, this side of the product side, so that sulfur will be balanced?
4.
Yes, that's correct. I will have to write 4 here. I've written the 4.
I'm wrong. Wait, I'm wrong.
Yes, if you write 4 there, 4 times 2 gives you 8 sulfur now, is it not?
Sulfur 8.
If with 4 here, sulfur is now 8 on the product side, is it not?
Yes, but the one that has sulfur 8.
On the reactant side, it is already 8 now. It's already 8 on the reactant side, isn't that what we said? Then on the product side, it's also 8. Can I hear you better?
The one that has 8, apart from the C also before, but the middle one is not yet balanced.
Which one is not yet balanced?
Like, except I put a different number for the middle one.
Which middle one?
The dash sulfur 8.
How many atoms of sulfur do you have in the reactant side? I ask you again. 8 on the reactant side. How many atoms of sulfur do you have on the product side?
8.
So sulfur is balanced. Why are you confused now? Sulfur is already balanced. You have it 8 on the reactant side. It's also 8 on the product side. So it's balanced. You need to check another one. Sulfur is balanced because it is 8 on the reactant side and it's also 8 on the product side. That is sulfur. Now check carbon. Remember, initially carbon was balanced before you wrote a number here. Now let's check again. How many atoms of carbon do you have on the product side, on the reactant side?
1.
Okay, 1 atom of carbon on the reactant side. Let's go to the product side. How many atoms of carbon?
8.
Carbon, I mean, only carbon. I'm talking about carbon. I didn't say sulfur, carbon.
4.
4, how do you come about 4?
1 times 4.
1 times 4, good. Is carbon balanced?
Carbon balanced? No.
So what do you think we should do to make carbon balanced?
Put 4.
Where? On the reactant side, I should put 4.
Carbon.
I should put 4 on the reactant side. Now let's check again. Because after putting anything, you have to check everything all over again. You have to check everything all over again, right?
Yes, sir.
So let's check again. How many carbons do we have on the reactant side? 4. Let's check the product side. How many carbons do we have on the product side?
4.
So carbon is balanced. Let's check sulfur. How many sulfur do you have on the reactant side?
8.
Let's check the product side. How many carbon do you have on the product side?
8.
8. Are they all balanced now?
Yes, sir.
So they are balanced. So we can tick that. It's balanced. Let's try again number 6. Question number 6. Shall we?
Yes, sir.
All right. Starting with sodium. How many atoms of sodium do we have on the product side, on the reactant side? How many atoms of sodium? No, this is not number 6. I'm talking about number 6. How many atoms of sodium do you have on the reactant side?
Sodium. 1.
1. We have sodium 1 on the reactant side. On the product side, how many do we have?
Product side, we have 1.
Have you checked very well the product side? How many atoms of sodium do we have?
We have
2. 2, okay. So since we have 2, is sodium balanced?
No.
What do you think we should do?
You're supposed to add 4.
I should add what?
Add all 4. Add 2.
Where should I add a 2? On the reactant side or on the product side?
On the product side.
Okay, you said I should add 2 here. That's what you told me to do.
Yeah.
If I add 2 here, how many sodium do I have here now?
4.
How many sodium do I have sodium on the 4 on the product side. How many do I have for the reactant side?
On the reactant side, you only have 1.
So what do you think? Is it balanced, by the way?
No.
What do you think I should do?
I'm supposed to add 4.
So I should write 4 here, right?
Yes, sir.
Good. So let's check. How about oxygen? Because after adding any number, you have to check again. Oxygen, how many atoms of oxygen do you have? In the reactant side, 2. Let's go to the product side. How many atoms of oxygen?
1.
Are you sure?
I'm supposed to add 1.
Are you sure? In the reactants, the product side, how many atoms of oxygen do you have there? 2. Is oxygen balanced?
Yes.
Once oxygen is balanced, and if you don't need to write any other number, you can leave it, or if you like, you can just write 1 to show that it's only 1. Just like for that sulfur, we didn't need to write anything, or we can just write 1, but there's no need writing 1 if it is 1, because 1x is the same thing as x. Do you understand? If it is 1x, you don't need to show the 1, you can just leave it as x. Okay. Let's look at number. Which number can I show you now? We've done 5. We've done 4. Can we look at number 7? Let's look at number 7. What do we do? Let's balance number 7.
Number 7. Okay.
Let's start with nitrogen. For the reactant side, how many nitrogens do you have?
Put 2.
On the reactant side, how many nitrogen do I have?
We have 2, so we're going to balance it with 2 by writing 2 there.
Why do you think we should write 2? Have you checked the product side?
Yes, sir.
So why do you want to write 2 here?
I don't know. So that the oxygen will be balanced or something.
Let me understand what you mean. Where do you want?
I want to balance.
Go ahead, I'm listening.
So we can balance the oxygen.
Okay, let's see. So you want me to put 2 here. If I have 2 here, right?
Yes.
So
Yes.
altogether, how many nitrogen do I have? On the
4.
on the reactant side, 4. Okay, so when we get to the product side, how many nitrogen do I have there?
You have 2.
So what do you think I should write here? I should write 2 there. Now when I write 2 there,
Yes, sir.
nitrogen is balanced, is it not?
Yes, sir.
Then you have to check for oxygen. How many oxygen do I now have?
5.
Are you sure?
Then
How many oxygen do I have? Say it again.
10 oxygen.
10 oxygen. How did you come about the 10? How did you come about the 10?
5 times 2.
We said 5 times 2 to give 10. So we have 10 oxygen atoms on the product side. How many oxygen atoms do we have on the reactant side?
2.
Is oxygen balanced?
No.
So what number should I write to get it balanced?
5.
I have to write 5 here, and then it will be balanced too. After you've written the number, you check again to make sure it's balanced. On the reactant side, we have 4 nitrogen. On the product side, we also have 4 nitrogen. So nitrogen is balanced. On the reactant side, we have 10 oxygen. That's 2 times 5, 10. On the product side, we also have 10 oxygen. That's 5 times 2, 10. So it's balanced. Everything is balanced. I hope it's getting clearer.
Yes, sir.
Are you really getting this? Can we do one more?
Huh?
Or you can do the rest by yourself?